Hello, this is Meade Mods doing a new video on the Meade LX850 mounts. I have 3 of them here on the bench that came in for repairs. And I've got one broken down. We're going to start with that one and then move over to the second one, which is going to show you what it looks like before the mods. And then the last one, of course, with everything done and completed with all the upgraded mods. So, the one I have disassembled here, we're going to start off with the center nut, which is one of the main issues with these mounts. That's what I call the center nut. I don't know what Meade calls it, but that's what I'm calling it, because that's the best term I can come up with. So that center nut on the threaded shaft there, if most of you know, these mounts suffer from rocking back and forth of the mount. So when you go and unclutch the mount to align on Polaris, before you do anything, if you grab your mount, you can actually shift it back and forth. And that's a big problem. So all that movement of the mount is a bad thing. And you can rock it side by side too, side to side. So there's a lot of side to side motion as well, which is also bad. So they're relying on the pressure of this clutch to hold everything, in place, which is why you have a hard time adjusting stuff. So what I do is I put shims in here, which is the back of the clutch. This is your clutch plate. So you have your pins here that go inside of the mount right here. This is like a 6-shooter style setup here. Those pins go in there, and then this plate goes on the side inside that hole. So I shim this out to bring the plate out further and then test it. And then in extreme cases, you got to put shims on this side as well, which is actually what I had to do to that mount. So, and the shims actually keep the mount to one side so that when you clutch it up, everything stays symmetrically centered inside the mount and there's no side-to-side motion. And then this is the original center nut, and it's counterbored on both sides. Okay, so that fits in there, but there's a lot of slop. There's a lot of movement in there. So, and the counterbore on both sides, you only need the counterbore one side. The reason for the counterbore is so that you can put the tap on there and cut your threads without it walking. But because they counterbore both sides, you're only left with about a 1/2 inch of threads in the middle. That's not much. I've had a couple mounts come in where that threaded shaft actually stripped because there's not that much threads on here holding it on. So my new center nut is only counterbored on one side and it's threaded all the way through on the other side, so that you have more meat and potatoes and more threads grabbing onto it to correct the threads from stripping out. And it's machined a little bit thicker, so it doesn't go right in. So in most cases, I just take a Dremel tool with a sanding wheel and just enough to remove the paint, the anodizing on here. And sometimes it slides right in place and it's pretty snug. So most of them I have to take just the anodizing off, and some of them I got to do a little bit more than that. But you want it to be pretty tight, but not tight enough to make it bind. So, and go through some of the adjustment processes. I have the back plate off to make it easier. So when you take off the cover plate for the motor assembly, you'll find the motor control board under that plate, and then you look down inside of it. But I've taken the back plate off to make it easier. So there's a little grub screw there, and it's got a nylon tip on it. You can see in between there. And then this mount, it's not even touching. So what that does, that actually will adjust the box up and down, and it will actually take out the end play or the backlash where the worm drive meets the worm gear inside the mount. Okay, that's the first adjustment you make when you're adjusting this. And I'll show you again on this one. And then the second adjustment, what you do is, let's see here. Let's see. You remove this nut here, and I've actually got it pretty loose, so you got to put a pair of pliers on it, but be careful not to mess up the anodizing. So you take your spanner wrench, you put it in there, okay, and you adjust this, either loosen it or tighten it. Sometimes they're too tight, sometimes they're too loose, depends. So this adjusts the worm drive back and forth, okay. So how you figure that out is if you grab your mount and you turn it back and forth, you wiggle it. If there's a lot of wiggle in here, then you have to adjust this. And then your backlash is adjusted by adjusting the grub screw down here in the box, which flexes it upwards, like I said. And those adjustments are really important. So moving forward, so I will show you everything on this mount, what gets done. So this is what it looks like before the upgrades and before I disassemble it and take it apart. So the original center nut is still in there. And again, of course, when you unlock it, there's a lot of motion in there, rocking back and forth in the mount. So it might not look much down at the bottom, but up at the top, you know, and again, we're just looking at the height of the mount. So imagine your scope being up here and the OTA being, you know, however big your OTA is. So that's increased. The higher you go, the more that rocking motion is increased. So just like building a house, you know, you might be a half inch out on the downstairs. By the time you get to the third level, you're at 1.5 inches or more. So same principle applies to this, just on a smaller scale. So astronomically, you know, is that Polaris or is that Polaris? You know, where's Polaris, forward or backwards? It depends on where the weight's sitting. So, and that's also the problem why this knob is so hard to adjust, because when you're loaded up and you have your scope and your counterbalance weights and you got everything loaded up, and the weights are going to be sitting backwards or forward. It just depends on how your setup is. And that pressure being pushed forward or pushed back is putting pressure on that nut, which puts pressure on the shaft, and that's what makes this hard to turn. And that's a big problem. So in the other adjustment, again, so the center shaft also has a knob you take off with the same setup, and you put your spanner wrench on here, and you tighten it, and that moves that threaded shaft forward or backwards. And in a lot of cases, you have to put another washer in there to take up the extra space that's in there. So a lot of times I do that too. And that's the third adjustment you make. So that's pretty much explains how to set the mount up. So now this mount has been completed, and that's my Rayox saddle plate that I use for my 14-inch truss RC. I have that on there so I can test it with an OTA. I've got some OTAs in here for cleaning and collimation with rails on it that I can use. So I've got my CNC machine clutch lock knobs, and I have a lever lock knobs on the bottom, and I got rosette knobs for the RA and declination, and I've also got knobs for the original Meade plate. It gets rid of the giant Meade hex key wrench and that giant bulky Meade wrench you got to use on the knobs. So everything is completely tool free and a lot more user friendly. So this one's unlocked. So when I put the new center nut in, some mounts it eliminates it 90%, some 95%, some a little more, give or take. It's not usually 100% because I had to figure out what size to make the center nut, and I experimented with several, 4 different tests to get a good round number that would fit all the mounts. So this one, it rocks very, very little. So this one was as bad as the other one you saw. So this one's got very little movement, and side to side. That's pretty much doesn't exist anymore. I can sort of feel it. There was something there, but it's not like this. This side to side motion is just a lot. And that's kind of how this mount was. So I've almost eliminated the side to side on this one. I want to say probably 99%. It's pretty close to 100. And the rocking back and forth on this one, I would probably call it 98%. You know, it's not quite 100. It's rare I get a mount where it's 100%. This one I didn't have to do anything with this center housing. My new part slid right in. But like I showed you with this one here, every mount's different. It depends on the machine work. It depends on how much anodizing that's put on. So every mount's different. So this mount might be a little bit more than 95%, a little bit more than 98. It could be 100. I don't know until I get it done. So every mount's different. Again, once you have it loaded, and I'm going to demonstrate how easy it is to turn. You can turn this thing with 2 fingers. And this is very smooth. And there's no pressure on the center nut. There's no weight bearing, pressing against it forward or backwards. When I turn the adjustment, the mount moves with precision with every turn of this knob. So a good way to find out how much slop you have, you lightly tighten the clutch, and then you can turn the knob with your finger, and it'll stop. So we're going to call that, let's see, let me get to where it stops at 12 o'clock so I can better explain how to find out how much slop you have. Let's see here. A little bit more. So right about there roughly, a little bit more. So right about there, it stops right here. Call that 12. So you take your finger and push it around until it stops again, right about there. So that's almost about 7 o'clock maybe. A little more than 6. So that's actually about 11 o'clock. So 11 o'clock to almost 7 o'clock. So that's how much slop is in there. That's how much movement you have before it grabs. Right there. Right there. So you can see that, and every mount is like this. You can turn it until it just stops. So that's how much end play is in this mount rocking back and forth. And that's really bad. So that upgrade eliminates that. Again, here's the complete set of the lever locking knobs. This replaces the bolts on the bottom. And again, you don't need to try and get a wrench in there. This system is very easy to use. Basically, you just pick up on it and move it, and it locks down in place. Picks up and you slide it. So you unlock it. It's a little hard to do without holding the mount. So it's just a lever action. It's very simple to use. You snug it down, turn it out of the way, snaps in place. And that's how they work. So it simplifies the mount, all tool free. So if you're setting up in the dark out, you don't have to worry about trying to find the bolts and using the Meade wrench that comes with it, or any large wrench. You're scrambling around at night trying to get everything done and looking for trying to feel for it. And if you have your OTA up there and you're trying to get it on a saddle plate and you can't find the screws and you're holding the scope on your shoulder, I've done that. I've been there and done that, and that sucks. So that's why I went with the Rayoc saddle plate. It really simplified the setup. So how this works is there's a this pin here. It's a spring-loaded pin. So when I added a 1/4-20 screw in here, so nobody can walk up and go, "Oh, what's that?" And that was actually Steven's idea to drill this out, and I kind of mentioned it if he could do that. So basically, You unlock it completely all the way. You pull this little red lever back. That's the open position. And then when you go and set your saddle in here, it pushes on this pin, and then that puts it in a pre-loaded position. And then you can kind of let your mount go, let the scope go. And this pin actually grabs a hold of an opening on the plate and kind of locks it in. You can also put a screw on the bottom of the plate. That's why this is machined out on both sides. So you can actually have this plate in this direction or in that direction. Depends if you're left or right-handed. So it's got machine holes both front and back. And that's why this is like this. So it's, you know, if you want it on the left or the right, you can put it in any direction you want. So once you have your plate on and this has released the lever and put it in a preloaded position where you can let it go, then you go ahead and adjust your mount, you know, forward or backwards depending on where the balance point is. I put a piece of tape on my plate so I don't have to guess. That way I put it in the same spot every time. And then once you have it set up, you just continue to lock it down, and then that locks it fully, engages it. So it's a really nice system, very easy to set up. And when I'm at a regional star party or at a public event, I always put in my my quarter 20. I kind of forget where I got this from. It's from another company. If I can remember it, I'll post it later. But this is actually a really nice feature to have that. That way nobody can go, you know, because there's always that one person at any event that likes to touch stuff, and they walk up and go, oh, what's that? You know, somebody's going to walk up and grab that lever and unlock it, you know. I don't think your scope would fall out, but if you got it set up and it's tracking or something, this might slip. But that's what that's for. Keeps everything from falling off completely. But still, this is just there. It's just a safety feature. That's basically what that is. So, again, here's my CNC knobs before they're installed. And I don't use grub screws. I use a socket cap screw. It simplifies the installation. This is called a 6-shooter style knob. Very nice, very easy to install. And my last upgrade, which I don't have anymore, this was my last one, was the back cap. So this is a CNC machined aluminum back cap. And originally, I had these made so that I can replace mounts that had the big heavy back plate on it. If any of you recall, it had that big piece of steel on the back of it, and it had a little knob on the back you could take out. And that was just like extra weight that I thought was not needed. So basically, that's what I came up with this for, to replace that, to lighten up the mount. But now most mounts that come out, they all have the black plastic tail plug, you know, like this one here. So they all have that. So that's why I've stopped making, because most mounts that come in now, they're all like this. It's rare now that I'll get a mount in that still has that heavy tail piece on it. But this guy here got my last one. So anyway, so I hope this was very helpful in describing how the 850 works and what you can do to correct certain issues with the mount. Please leave a thumb up, leave some feedback. If you feel there's anything I've missed, or if you have any questions, please feel free to leave me a comment. And again, this is Meade Mods with the Meade LX850 upgrades and adjustments. Thank you. Have a great day and clear skies.